Howdy, we are looking at 2.3 today, but we're going to look back at 2.2 just because we're dealing with these same functions. We are still dealing with basic translations. So you'll still see the square root functions, the cubic functions, as well as the absolute value. And we're going to add in one different looking function, the cube root function. As you can see, the index of the root is here. We don't have to write it with the square root because it's understood that the 2 or the index is there. And still with what we did yesterday, we're still going to jump onto that. So we're still going to have horizontal movement as well as vertical movement dealing with the x and y values. Now as we get into 2.3, we're only changing two things. So we still have the h and the k that are here, so all those rules apply. And then we have this negative here. This is going to change the value of the y, which means we reflect over the x. And students are always like, well, how do we reflect over the y? That's if there's a negative value in here. And then we'll see that that would reflect over the y-axis. The other thing we're going to be looking at is this a value. And it is a factor. It's going to either stretch it vertically or shrink it vertically is what is done. And so basically, if the number is greater than 1, and then it will stretch vertically. If this number is a fraction, if it's in between 1 and 0, then it will shrink vertically. And we could say, oh, well, if it stretched vertically, it shrunk horizontally, and vice versa. But this is the verbiage that we're going to be using. We also have to keep in mind even functions will look the same, so it doesn't matter if it has that negative on the outside, because they already are symmetric to the y-axis. So we're looking at this first problem. We have two things that are happening here to the cube root function. It's going to reflect over the x-axis, so that's where this negative comes from, and it's going to shrink vertically by 0.3. As you can see, it's in between 0 and 1, so that's an example of it shrinking vertically. Here we have a cubing function. Here we have a reflection across the y-axis. So here's something to watch out for. And we have a factor of shrinking it vertically at 0.45. So we see we change that function simply by doing that. Now when we look at this function, right, we have a cubic function as I showed you earlier. And whenever in doubt of what a function looks like, you can either put it to your calculator or you can start plugging in points. If I put in 0, 0, and I know I get 0. If I put in 1, I get 1. If I put in 8, because cube root of 8 is 2. So we get those kind of ideas here when looking ahead. Here, we're simply going to negate everything, so this changes all the y values. So we see we have, and since it's an odd function, when we reflect it over the y-axis, it looks like we also reflect it over the x. So that's what makes it an odd function. And then here we have that negative on the inside here. That means we're going to have a reflection over the y, but since it's an odd function, it still looks like we reflected it over the x. And then we are going to be moving it to the right 4. So as you see, we scooted it over 4. They're counting by 2s here. In the next one, we're writing the function. So what is important is the vertex. And in writing that vertex, we're dealing with our h and our k values. And we see here, if we look here on this graph, remember we're counting by 2 here. If I look here, this is in between 2 and 4, so that's 3. That's where I get my h value. And my y value, I went up 2. That's where I get this positive 2. And as we're writing this function, we're simply replacing those h and k values and the negative on the outside, since, as you can see, we have reflected over the x. So the red is going up and the blue is going down. Here we're filling in the blanks here just by stating what has happened here. So we have a negative here, that's where we get an x-axis reflection, and we have this 3 as a factor as we're stretching by 3. As you can see, this answer is not negative 3. These factors will always be positive. That negative is letting us know what is happening with the reflection. Looking onto this absolute value function, we can see that we're using 5 units to the right, so that's what's happening here with this x minus 5. So we're subtracting a positive 5, so that's why we're going to the right. And here we're shrinking vertically by 1/7, so that's what's happening here. And once again, that is not negative. That negative on the outside is letting us know that we are reflecting across the x-axis. And then this outside, as you see, once again, we do not have a negative here. We're shifting vertically 3 units, and that negative makes it downward. In the next one, we're looking at a cube root function. We have a factor of 5. It's applied here. This 4, we are subtracting a positive 4, so we're going towards the right at 4. In the next one, we have going downward by an 8, so that's where this minus 8 comes from. And then we have shrinking by a factor of 1/4, and that's what happens here. On this next one down here, lots of ways that you could do this. You could plug this into your calculator and look at the graph that's there, or you can plug in a couple points, or you can use the translations. All of these are up to you, kind of are creating your toolbox or your Batman's utility belt. So here I just plugged in a 0, I got -2. I see, this is the only function here with that. Just to check it, make sure, I plug in 1, I get -3, and that makes complete sense. Here, same type of thing here, we're looking at it. This one we could just do by translations. I had to move to the right 2 and down 1. And as you can see, that is the only function that does that. And then the factor of 2 would be something more if you're dealing with plugging in numbers. Here's same type of thing here. This thing gives me the heebie-jeebies. I don't know what's happening here. So I plug in 0, I get -6. So I look for that. As I can see, I have a couple that had that same point on there, so let's do some more investigating. I plug in -1, and I get -5, and I see this is the only one that has that. Once again, very scary things over here. I don't know what to do. I'm just going to go back to algebra, and I'm just going to plug in points and make a t-chart, and I'll be able to do this. So I plug in -5. I do that, I get 0. So I know that my graph starts at negative, so I have 2 graphs that are doing that. Then I'm like, all right, well, let's investigate. Let's go to the left. Let's go ahead and smaller numbers, -6. I plug that in, I get 1. I realize that I'm going towards the left and not towards the right. Here we're looking at these functions. So if we have y is equal to negative f of x, that means that all y values are opposite. So what that means is that every point on this graph, I've simply changed this 2 to a -2. I've changed this 1 to a -1, this 1 to a -1, and this 3 to a -3, and all other points have done the same. The x values remain the same, so this new point becomes 6, -3, as you can see is here, 6, -3. There we go. And we just do that with each of those points. On B, we do the same thing, except we're doing it with the x values. When all the x values are opposites. So we go back to those original graphs, and this point now becomes -6, 3, -4, 1, 2, 1, and 3, 2. And as we do that, we see that this is the result. In C, we are multiplying. We're multiplying all y values by 2. So once again, the x values remain the same. I multiply this by 2, I get 6, so this is now 6, 6. I multiply this 1 by 2, I get 2, this becomes 4, 2. I multiply this 1 by 2, I get 2, this becomes -2, 2. And this becomes -3, 4. So when we're looking at C, we can see that this is the result of multiplying all the y's by 2. And then looking at D, plugging in x is 0, so we're looking for the y-intercept. So we're looking at this point right here, and so that value is 1. So when we plug in x as 0, what do we get for our y? And in this next problem, we're doing the same kind of thing, just a different graph. We're changing all the y values to their opposites. So just like before, this becomes -3.5. This becomes +3.5. This becomes +3. And 0 just remain the same. So it kind of hinges on the x-axis, as you see here. Once again, we're changing all the x values to the opposites. So all of these become -2.5, 3.5, -1, 0, +3, 0, and that continues. And we see that this is the result of doing that with their x values. In C, we're subtracting -2, so we're going towards -2, or subtracting 2 values from each of this. So we can look at this graph and we can just shift it to the left 2, or we can go to each point and we can subtract 2. So this becomes 0.5, this becomes -1, this becomes -5, this becomes -4, and this becomes -2. And so this is the result of subtracting 2 from x graphs, or shifting it to the left 2. And then here, we're looking at what were the intercepts if we do this to it. So this is telling us that we are subtracting positive 4. So we're adding 4 to the x value. So we have to look at the original x-intercepts, which were negative 3, 0, and 1, 0. And we simply add 4 to our x value. So negative 3 plus 4 is 1. 1 plus 4 is 5.